Okay, so now we've introduced composition of functions, and now we want to prove a theorem about composition of functions. So assume A, E, and C are sets. G from A to B is injective, and F from B to C is injective. Then composition is injective. So this is what we want to prove in this video. And sometimes when I prove this, people will point out that, what about the other order, right? We could have composed G composed with F. But remember, the names are not really playing an important role here. I mean, they're important for communicating things, but you should just think of G as the first function and F as the second function. And it's just saying that if both functions are injective, then the composition is injective. And it doesn't matter what letters I use or if I flip the order of the letters, it doesn't change the content of the theorem, right? Okay, so let's prove this. So let's look at the proof. So to show that F composed with G is injective, we must show that so for all A1 and A2 in A, if F composed with G of A1 is equal to F composed with G of A2, then A1 is equal to A2. Okay, so to this end, assume A1 and A2 are in A, and F composed with G applied to A1 is equal to F composed with G applied to A2. Okay, so by definition, this implies that F composed with G of A1 is equal to F composed with G of A2, right? Okay, so now let's remember, since F is injective, if F of B1 is equal to F of B2, for B1 comma B2 in B, then B1 is equal to B2, right? And so since G of A1 and G of A2 are in B, and F of G of A1 is equal to F of G of A2, we know that G of A1 is equal to G of A2, right? So since F is injective. All right, but by a similar reasoning, since G is injective and G of A1 equals G of A2, we find that A1 equals A2. And so hence F composed with G is injective. And that's it. Good. So we just had to peel back the injectivity of F and then the injectivity of G to see the injectivity of the composition. And this also feels right because that's what it feels like you should be doing when you are working with compositions, right? So there's some good intuition there.